All right, hello friends. Oh, my screen just went white. That's not great. I'm just gonna wait for a second and see what shows up on YouTube. Okay, it was just on my end. You guys can see everything fine. Welcome to today's live stream. I'm really excited because I think we're actually gonna wrap up this gosh darn co-occurrence graph this time. And the reason I think that, I dropped something, I got so excited, is because somebody, Ryan Carson, hi Ryan, wrote a helpful fork of the kernel that I've been working on to help us speed along so we can actually get to some graphing and look at pretty pictures instead of just like futzing about with these friggin' dictionaries. Okay, so let's go to my work. I'm signed in, and this is just the kernels page from the kernels tab. And there's my work. And oh, that's last week. It's in here somewhere. There we go. Oh, I guess it's been a minute since we worked on this, huh? And it's starting. And if I look at forks, yeah, there we go. So this is the fork I'm going to work from. And my thought was that, so I'm just going to fork this fork. And then we can figure it out later how to merge it back. Well, I'm just gonna Ryan's. Is that gonna be more than 60 characters? It's not. Notebook. Is that more than 60 characters? It's not. Excellent. So my idea is that I'm just gonna read through this because I looked at it very, very briefly earlier and I was very excited by what I saw. I saw some outputs that looked like the thing that I wanted them to look like, that I was having a hard time getting it to look like. And then we can look at the thing. Oh, look at getting our graph to look good. Oh, and the other thing I wanted to do is I was at JupyterCon, and at JupyterCon I went to a workshop on NetworkX, which is the there we go, which is the networking package that we're using. So I have a nice example notebook with plenty of code examples we can copy and paste and use to make our network look the way we want it to. Oh, that's taking a second, huh? Well, I've got internet connection. Oh, of course I do, because I can see the YouTube video. One sec, let me just check for something real quick on my phone and make sure everything's tickety-boo, because this is taking a minute. And we had some, there was something going on earlier that's, it's fine and it should be handled now, but I want to double check that we are not having anything unfortunate going on right now. All right, no, yeah, it looks good. Let's try restarting this and see if that'll help. That one hasn't launched either. Okay, there we go. We just needed to restart it real quick, and then it worked. So let's do that. Okay, so we've got all our imports at the top. Excellent. Panda, Spacey, NetworkX. Oh, imported as NX. I don't remember if I did it that way or not. Maybe I did. It's been, what, a month since I worked on this project? So there's definitely going to be some spooling up. Dictionaries, itertools. I remember all of this nonsense. Matplotlib. Ugh. No, it's fine. Matplotlib it's a useful tool. I met with the Matplotlib maintainer at JupyterCon, and I was maybe a little sassy because maybe I'd had a drink, but it is a useful tool, and I appreciate that it exists, and I do use it. I'm just not a huge fan of MATLAB, and Matplotlib is very MATLAB-y. NumPy, and from math import log. I don't think I imported that, so we're going to do something with log transformation. All right. So reading in the data, that's the same. This is what's new. So this was the original method that we were using that worked but didn't iterate correctly. And here's Ryan's method. Okay, so this is a list of lists rather than nested dictionaries, which is what we'd ended up with. And not just nested dictionaries, nested default dictionaries, which is what we were running into trouble with. So instead, we're doing a list of entities, outputting a dictionary from those. Okay, so we are starting by creating a default dictionary with integers. Does that sound right? And then we're going to look at the inputs, and we build a co-occurrence matrix. So they're sorted. And we're going to take 2, and we're going to look at all the combinations. I'm assuming that's the same as combin in R, C-O-M-B-N. And then if we find it, we add it. And then if we don't find it, we add it. And then if we do find it, we add 1 to the count. So this is the... So this is a default dictionary. So this okay, so we're adding entries to the dictionary. It's a dictionary with 2 keys. Hi, Omar. And then, oh, okay, so this is a co-occurrence matrix, and the result is, so we're going to look at all the pairs and the count in items from this dictionary that we just built from our inputs. Ryan says it's pretty much the same as before, except you input a list of all of the lists and it automatically unpacks them and adds them to the default dictionary. Okay. Okay, that makes sense. So instead of trying to iterate the count, we create the count and then we add it. Oh, we're getting some echo. One sec, let me change this window size so I can actually see more than one line of chat. Can I change that? I cannot. Well, that's a feature I don't want. Can I make this smaller? Sorry, I'm doing things on my other screen, one of my other screens, to look at it better with my eyes. Omar says there's a lot of echo, but somebody else is not getting echo, so it's the star inputs that unpacks it. Oh, I see. Okay, interesting. Not something I've worked with before, and it looks like we don't need this maybe, so I'm gonna get rid of it. Delete. Oh, can I not edit? Am I not in this? Okay, it's just a little bit of lag. Oh, and that might also be because I'm streaming and I'm putting a little bit of network load on. Okay, and then we're gonna test it. So let's run this. Oh, probably the first thing I should do is import everything, and make sure we have data. And then I should probably, return result invalid syntax. Yeah, it would be because I made a mistake. All right, so if we do A, B, C, D, D, C, we see A and B has a weight of 2. So, because A co-occurs with B once in this string, and it co-occurs once with B in this string. And then we have C is 3 because we have A and C here, and then A and C twice here. So that looks good. Oh, good. Excellent. Omar fixed the echo. I'm glad it wasn't me, because I have definitely uploaded videos with super bad audio before. And then B, we should have D5. D5. Okay, that's correct, because it co-occurs with 5 Ds. And then C. Excellent. So D is not a key because all of the co-occurrences are gotten to before then, right? So it would be like if we were looking at all the combinations of 1, 2, and 3, and that's what we had, we'd have say, okay, 1 and 2 occur together, and 2 and 3 occur together, and then that's all the combinations. We wouldn't have to say like 3 and 1 occur together. Oh, we would in fact have to say that 3 and 1 occur together, but we would do 1 and 3 occur together, and then 2 and 3 occur together. But we wouldn't have to say 3 occurs with anything because we've already got all of the things that it co-occurs with. And I think that is happening because you have sorted it would be my assumption. Yeah, so I am not worried that D is not a key here. That's fine for me. And I think NetworkX handles a lot of stuff there, she said, full of hope. Okay. So this is, now we're actually working with our data. So this was just sort of the function and make sure that it worked, and the thing that almost made me cry. I'm just going to delete this. We're going to pretend that doesn't exist. And this is actually the thing we're doing with the data. So first we're removing uniques. So I was doing something where I made sure that they were all strings and stripped lower and white space, but turns out this ruins it and reduced most docs to few claims for some reason. Interesting. I don't know why that would be, but I believe that it is so. And then we loaded in the named entity recognition, and this is, English, and this is web and social media data, which makes sense because the like Snopes things are from web and social media, so I'm fine with that. But yes, also something somebody brought up last week was, or like a month ago when I was working on this last, was that we might want to look at augmenting augmenting entities. So if there's some sort of geopolitical entity that's not in the dictionary, then we might want to add it. Which is something we could look at in the future, but first I just want to see some graphs. And then we initialize a counter and lists for our entities. So this is the thing that we are going, this structure is the thing that we are going to pass into co-occurrence. It's a list of lists. That sounds right. And then we have the number of claims. All right, and from this point on, it's been redone. So something in the casting to strings was causing issues. I don't know what that is. These look unique. And we can, oh, I see. So examples shows up a lot in our text field, and it is counted as an entity, so we should probably remove it. So I'm just gonna leave a little to do for myself. To do, remove all the examples from the text. And this may be something you already did, Ryan, and I just haven't gotten into it yet. Okay, looking at number of times each entity appears in the total corpus. All entities appear as spacey tokens, hence needing to cast as string from dictionary. Oh, interesting. So spacey has like its own interesting little data type that it uses. Spacey seems to have an error at the 3K document mark related to this, maybe. Let's go to that URL and find out what's there. Argument string has incorrect type. Expected Unicode got string. This seems like a Python 2 thing. There's a small bug where Unicode is expected and string is provided with a one-line fix. Still, I see the same behavior at multiple occasions. Interesting. So in Ryan says, as a heads up, some of the functions take a few minutes to run on Kaggle or click on my laptop, so I didn't optimize. Nah, that's fine. I don't mind things taking a few minutes to run. So I am just gonna run that while we read this. Interesting. So something at 3,000. So In Python 2, the encoding for string was actually ASCII. In Python 3, it's assumed to be UTF-8. So in a lot of places where in Python 2 you would use Unicode, in Python 3 you can just use string instead, and that's the preferred method. Interesting. Thanks for the report. Instead of modifying the training code, we should just be able to simply add a U before text in the training data, e.g. U who is Shaka Khan. So this is going to change the type of the string to Unicode. Automatically locked. Interesting. So we might want to cast them as Unicode, possibly? Okay, so that's something to think about. Look at possibly casting tokens to Unicode. Speaking of the way that programming languages handle text data, I don't know if any of you were here when I was looking at Julia like a minute ago, like several months, maybe 5 months. And the thing that was just sort of like a deal breaker for me was that it doesn't handle Unicode very well, which is someone who works with a lot of text data I can't deal with. I need something that can handle Unicode. Otherwise, you can't work with most languages. Okay, so these are things that appear at least twice. So while this is running, I'm just going to sort of go down and read through the code. So most popular entities, so we're sorting the dictionary. That's a Python 3 something thing that's relatively new. Right? Sorting dictionaries is relatively new. I'm looking that up. I'm getting more Pythonic. I'm learning. Custom sorting algorithm systems, blah, 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 blah. Simple sort, utilizing other animal, blah, blah, blah. Oh, no, it's sorted dictionaries as a native data type that's a new thing. I'm pretty sure. So that the dictionary is alphabetical. Like a dictionary is in real life. And you, as a human who exists in the world, might expect a dictionary in Python to be. Sorry, I'm really salty about this. My intro NLP class, the fact that dictionaries were not alphabetical caused me a lot of grief. Okay, and then we're looking at the number of entities that appear at least twice. Okay. How many entities appear per claim? So blank strings, non-breaking spaces are popular. Why would non-breaking spaces show up? So, sorry, non-breaking spaces are one of the joys of NLP. And when I say joy, they're not a joy. You know, actually, I'm going to move this so I can see so I can tell that this cell is still running, and I do expect this to take a little bit because I can see my little stop sign down here. So I'm moving my microphone so I can keep an eye on it so I can make sure I can run the next cell when it finishes. Non-breaking spaces. So you'll get them in Mongolian text, which I would not expect to see a lot of on Snopes. I don't know, does Snopes have a large Mongolian section I don't know about? You'll see them sometimes as joiners between modifiers in emojis. So like flags, sometimes you'll see non-breaking spaces. Things with skin tone, sometimes you'll see non-breaking spaces. But I don't remember there being a lot of, whatchamacallums. I don't remember there being a lot of emoji in the Snopes data. Let's check it out. Let's look at our data. Take a quick peek. Just open it in a new window. Yeah, I remember these mostly just being sort of like newspaper headlines. Interesting. So one thing that this could be is if we have Unicode text and it's being stored as ASCII, this could be a weird rendering of the unknown character. Ooh, it's done. All right, so let's see our most popular entities. So here we have examples. Okay, so this is a lot of spaces. This is a lot of spaces as well. Interesting. So this could be a rendering of the unknown character. So this could be something in a non-ASCII font, but I know that kernel supports full Unicode. Like you can paste emoji and then you can see them in the output. Okay, but we see this /XAO, which is something you get from HTML, I think. I think that's an HTML artifact. The joys of text data. Let's try it. Non-breaking space. Blah, 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 blah. Unicode representing spaces. They're an efficient way. 2.7. Yeah, so it's an encoding issue. Just doing encode UTF-8 without replace seems to cause it to spit out even weirder characters. Oh, I think that's the character for the dash, so it's encoding this to UTF-8. Straight up, like each of those characters. Yes, okay, there's definitely an encoding issue in here. That's great. It's not great. It's fine, though. There's a really nice library for this, and it is called Fix That For You, I'm pretty sure. Let's see. Yes, and then TY, what's in here? Let's just try fixing text, and let's just try copying and pasting this and see how it do. That didn't do it. Because usually it can catch a lot of the sort of like, what do you think that is? You think that's just spaces? Okay. Well, that's something to think about for later. All right, so number of entities that appear at least twice, 688. Okay. And then we're looking for the entities in each claim, and we're going to plot a histogram of the number of entities in each claim. And I'm actually going to do this just to make it a little bit easier for me to read with my... Look how much code it is to plot a histogram. I should just be able to say, histogram, here's my data frame. That should be all I have to say. Sorry. Like I said, I appreciate Matplotlib, and I'm happy it exists, and I'm glad I don't have to code it from scratch, but it is frustrating for me as someone who comes to Python from R. Okay, and now we have exploring demonstrating with a small subset, then performing calculations with a whole data set afterwards. Okay, I like that. Listing claims is a list of their entities, and this will go through and it'll take the first 5 claims, 6 claims, the first 6 claims. Ryan says, you can, I just wanted to change things a tiny bit. Yeah, no worries, no worries. And then we're going to make each of them a string, and let's see maybe if we make them Unicode instead. You know what? No, I'm not going to mess with it right now. And we're going to create a list of all of these entities as strings, and then we're going to add them to our list here. Oh, okay, so for each claim, we are going to add it to our empty list that we created up here. We're going to loop through it. And then we're just going to add some fake co-occurrences. And then we're going to look at that list. Can do as one-line list comprehension, though maybe not as readable. I agree, that isn't as readable. And it does the same thing. I don't like one-line things. Nothing drives me as bonkers as people that do that. That drives me directly around the bend. No, I changed my mind. There is something else that drives me more bonkers. People who use, there's an assignment variable in R that you can use to assign to global scope from within a loop or within a function. When people use that, that's the thing that drives me the most bonkers. But I hate it when people do that thing as well. I've got a lot of pet peeves. Mostly people don't do them, which is fine. Which is probably why they're pet peeves, because if everyone did it, it would be fine. All right, and then can filter out claims with only one entity, nothing to co-occur with. Yes, that makes sense. So you might want to keep this if you wanted to see like what things show up a lot in a lot of different claims, and you might use this to show like this is something that people talk about a lot, and then have the lines be the co-occurrence. But I'm fine with this, especially since we have what 688 claims. And then we're going to generate a co-occurrence dictionary of dictionaries. And then there's something funny happening with the non-breaking space. Always is. It's a pain in the butt. And then we want to filter out entities with less than 2 weights so that co-occur with something less than twice. Just to make sure we don't have too many things in our graph, because it can be very easy to make an unreadable graph, as I think we found out in the very first stream in this series. And we can also use deleting co-occurrence edges with a small weight rather than making a new dictionary. But we're not using a lot of our disk space, so I think that's fine. We can just keep it. Memory is not our what's it called? Choke point. The small place in the thing that is the bottleneck. It's not our bottleneck right now. Okay, and then we're going to so adding things that have a weight of greater than 1, so 2 plus. And then adding those. Okay, so to create it, if it's always adding entries and then looking at it. I think I need to see what this looks like. Oh, and here's our histogram. God, that took forever. It's not on you. Okay, so most of our entities have, some of them have 0, which makes sense, because if I just say like, I'm trying to think of something that wouldn't have any entities in it. If there's no entities in our claim that are in our dictionary, they're not going to show up. So most have 2 plus, and we've got a mean right around, it looks like 3-ish entities, which is sort of interesting. And going further down, so listing claims is a list of their entities. So Georgia first, US Muslim, Georgia first, US Muslim. We do have some duplication here. And I think getting rid of the examples will probably help it. I wonder if that was formatting in the original data file. I wonder if that's white space. Somebody's very nice thing, because this is scraped data, and with scraped data you'll get, again, a lot of weird HTML artifacts. Often you will get weird HTML artifacts. All right. Oh, that's right. We intentionally created some duplication here for purposes of making sure it looked good. Something funny with non-breaking spaces. Yeah, it looks like they're only being counted. We just need to get rid of them, basically. I think if we get rid of examples, we will do ourselves a lot of favors. Oh, and these are all the things with weight of 2 or more. In this case, it's only 2. And then summing all core occurrences into order to see the most co-occurring edges. So Georgia co-occurs with 16, Muslim with 4, US with 2, and that day with 2. And then the whole data set. This is going to take a minute, I'm assuming. Not sure where you want to go from here, but going to have a little play with NX graph and then some actual graphing, which is excellent. I should probably have redone getting rid of the examples. So at which point does it make sense for us to get rid of the examples? This might not be helpful here. Probably probably in doc.ents. So let's actually stop that. I don't want to run that right now. So I want to remove examples every time it shows up. And the other point at which I could do it that might make sense is in the original data set. That might actually be easier, so let's try that. Because I think there's probably going to be something built into pandas. Pandas remove all instances of a word in a column. Yeah, that's exactly what I want. You can use replace and pass the strings to find replace as dictionary keys dot. What? What is Deepu says, where can I access this code afterwards? You can actually access it right now. It is if you search on Kaggle for, unfortunately we can't paste links into the YouTube chat, which is a little bit unfortunate. Named entity recognition, and then search for Ryan Carson. Will it be in the top? It won't be. So if we go to kernels, actually I think I can just go to what it's called from the fork. Oh, that's right, I haven't committed it yet. No, ignore that. So I go to my work, and then it's further down than I think it is gonna be. So if you search for named entity recognition, Rachael Tatman non-admin, and then you look under forks, it is the first fork. So the code that I'm working for today. And that's already public, but the version I'm working with here is not. Oh, all right. I was being saddened by the fact that we have to use regular expressions of a dictionary in order to do replace. I mean, you do what you gotta, right? Okay, so it's gonna be data.replace, and we're gonna replace, what does it look like exactly? I wanna make sure I'm replacing the right thing. So first off, let me look at data.claim.head. Haha. Oh, it's truncating it. Can I see just the first one? Where is this examples coming from? This examples nonsense that we're seeing. See examples. See examples. I don't know where it's showing up. But let's get rid of it, maybe? So let's try replacing examples with nothing and see if that works. That does not work because if group is not none, missing, oh, should I escape it maybe? Yeah, all right. So I think I have now replaced all of the examples. And hopefully that will help. Remove examples. And let's see. Pandas. Deepu says, hope I didn't waste your time. No, not at all. Not at all. Happy to have questions. It means I know people are awake and watching. And I'm sure somebody else also had that question. Oh, what was I looking for? All right, pandas. Replace non-breaking space. That is the thing that I want. All right. I thought it was doing that properly. Anything I'm doing wrong? You have to use shift. Blah, 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 blah. You don't have the Unicode string, but UTF lists the bytes, which are what strings are in Python 2.x. Is 6 characters that are not any type of escape code. No spaces must not beginning and end my string. First and last. It might be worth it to remove punctuation. I know we did that earlier, and I think I deleted it. No, let's try this. And see how that goes. All right. And let's now check the entities. Okay, well, now they're just one non-breaking space, so that's something. Interesting. Interesting. Okay, so what's left is we have that. So maybe it's the second parenthesis that's giving us a headache. Let's try getting rid of that and see if that helps. Whap. Okay, so we still have empty entities. Eating Takis brand corn chips causes ulcer and cancer in children. Space, 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 space. C. One space. It's not just the existence of white space. It seems to be white space at the end and something in here that we're not seeing. And I don't know what this is. Is it just a bunch of spaces? Python, remove all non-standard spaces. I think that might be it. I think we might be having trouble with a hodgepodge, a potpourri of different space characters. And Spacey's like, this is special. I will save this out. I want to remove all weird spaces. Non-letters from a string. That's not necessarily what I want. Any non-white space character. I want all the non-standard spaces. What would you guys call that? Ooh, how about replace all white space with just regular spaces? Yeah, how about that? That'll help. Yes, 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 yes. The problem is if this uses a Unicode range, we're gonna have trouble. Simple possibility if you'd rather avoid regular expressions. Yeah. Let's try that. That might be a good, right. And let's try, and let's still do data.replace because there's something with this dictionary format that is, it's still needing to do. Equals capital T, lowercase everything else. And so we want to replace one or more white spaces of any kind with, oh, nope, that is the key, one space. And they're also stripping space, and we're not gonna do that, maybe? I might regret that. I might come back and do that later. All right. Do we still have weird examples? No, not that I can see. That doesn't mean they're not there. It just means I don't see them. So that's good. So let's get rid of this and let's see how this goes. So it's gonna take a minute, and hopefully it'll work well. And then we'll look at the most popular entities, and hopefully we'll be happy and not sad. And I might get rid of this just because it... Oh, do we use that ensign claim later on for something else? We use claim ends. We use multiple. Yeah, I think I'm just going to get rid of this because I think it's interesting, and I'm glad that you did it, Ryan, and thank you. But I am not, at the moment, super interested in that because I want to get to the graphing. And I have an appointment at 5:15, so I do need to be there. I do need to wrap this up at 5 rather than going over like I sometimes do. All right, so while that's going on, we had problems here. Oh, no, we didn't have problems. I stopped it. Oh no, something is wrong. Please save your changes locally and refresh the page. Oh, I get questions about this sometimes. So to save your changes locally, what you do is you download the IPython notebook, and then we're gonna refresh it. And it won't necessarily save our changes depending on when we lost connection, and I'm not entirely sure when that is. But what we can do is I can upload the notebook I just downloaded, and I won't have missed anything. So let me upload. And you can't see it on my screen because I'm just showing you guys the one window. But I'm just going to my downloads where I downloaded it, and it's called kernel.ipnb. I'm gonna sort by the time I downloaded it. Oh my god, I need to... Wow, I really need to clean out my download file. It's been a while, apparently, since I did it. And it's just gonna take a couple minutes to show me all of the files I've downloaded. I have 8 copies of my CV downloaded? Wowzers. All right, this is a glimpse into my personal file management, which is maybe not the best. I've also downloaded kernels before, so it's... There we go. But they are our notebooks and not the other kind of notebook. All right, well, let's just run it from the top. All right. Oh, this should say that it's running. But we can see that the code is being run in here, and I think it will show everything once it's done with all of them, so that may take us a minute. But you can see that the stuff that I did with removing the examples and removing the weird white space is still in there. And the question that I have is whether or not non-breaking spaces fall in this regex, and I think they do. I think they do. Let's find out, because this seems like a useful question for me. Includes non-breaking space, because we were running into some issues with that. Nope, I don't care about Java. That's not fair. I do care about Java. I just don't care about how to do things in Java, and I keep clicking on that answer. Replace with regular breaking spaces. The S pattern matches any. Looking. No matter what, I cannot get non-breaking space in the parser output. Parser seems to replace non-breaking spaces with normal spaces. It's being replaced with a single non-breaking space. The /s pattern matches any blank character, including non-breaking spaces, which are then converted to regular breaking spaces. Okay, good. That's what I wanted to know, and I'm happy to hear that. Are you still chugging along? Yep. I bet it's probably graphing now. But if we look at look how good our entities are. We don't have example open parenthesis s nothing. So that's exciting. We've cleaned up some of those. That's great. Oh, and it's doing this bit here where it's looking at the co-occurrence. Interesting. And I'm not entirely sure what this is. And again, I don't think it's a memory issue, because again, if you look at our disk space, we're not running out of disk space, and we haven't been getting errors about disk space, so I'm not super worried there. Most popular entities that appeared at least twice. So we're gonna get It'll be going through the little one, and then it's going to try and go through the big one. And then we looked at some graphing. So I'm going to look at your graphs. Obviously not the actual graphs because they're not displayed right now. But, oh, actually what I can do is look at the compiled notebook. Fun fact about the compiled notebook is that you can, while you're compiling your notebook, still play in this notebook because they're being run on completely separate instances. So when you commit, you get a completely new version run top to bottom that has nothing to do with your current environment, whereas the environment that you're playing around here, like obviously the code changes change what you're doing the commit, but if you like play around in the console and do something, it's not going to mess with your commit. So a fun fact in case you guys were wondering. I know it was keeping you guys up at night. Can I still code while I'm committing? You can, in fact. So let's look at this graph. Scroll, 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 all the way at the bottom. There we go. All right. So we can see some of the things that we got from the graph, and this was this the baby one or was this the whole big one? Let's see. Most frequent, sort of co-occur, top co-occur. Okay, so this was from the whole big one. So it was looking at the top 11 entities. Oh, no, it was getting rid of the one that was just like a bunch of spaces, which hopefully we have gotten rid of via our very fancy text cleaning. I think it was just this week I just told someone, don't use regular expressions for text cleaning. Listen, it's still good advice. I don't recommend using regular expressions for text cleaning, but in this case, I think it was reasonable. And then the graphed edges are co-occur edges filtered for K in top co-occur no space. Co-occur edges filtered, and that is up in here. So it's from our weight. So it's things that have a weight of more than 5. So it is possible that we might end up with entities that never co-occur. I always see this examples thing. This might be an artifact of a specific site, maybe, that they say link to examples. I don't know. Okay, and then we get the top 10 co-occurrences because it was 1 through 11, and we got rid of the one with just spaces. And then we use a spring layout, which is just I think that's repellent, so you want things to be as far away from each other as possible. Does that sound right? Someone who knows NetworkX better than me? And then normalize and scale line weights. So for each edge, if it's not self-co-occurrence, then you take that as the weight, and so this is the normalizing. So you are, for each weight, you are subtracting the minimum of all of the weights from that weight, and then dividing by the maximum minus the minimum. So that is, so the minimum weight here will be 0, and the maximum weight will be 1. So you're moving it between 0 and 1. So that's the normalization. And then the scaling, you're multiplying it by 6 and adding 1. So you don't actually have 0 to 1. You have 7 to 1. Nope. You have 37 to 1. I can do math in my head. That's absolutely why I became a data scientist, is to do all of the math in my head. And then the lines are what I would probably call edges in this case, and it looks like it is called edges a lot. So it's just the how thick the edge is. And then scale the node weights on a log scale. We got to the log back from the very beginning of our adventures today, when we imported log, and I was like, something's gonna be log scaled. And that makes sense because you don't, well, I don't know. So for something like this, you might actually not log scale, because I'm guessing that these are going to be the biggest nodes. And for something where you're showing sort of the absolute count, it might make sense not to do the log scale. We'll see. I'll try it and see how I feel about it. And oh, so you didn't actually log scale. You did at some point and then you undid it. So this is like that. Yeah, Ryan says it's commented out. I figured it out eventually. I got there. Yeah, and I agree. I agree that this one is throwing off the scaling. Because you can see the co-occurrence is very thick, but then like the number of occurrences is very small. So it seems to always co-occur with Donald Trump and Hillary Clinton. This must be an artifact of a specific site or the scraping maybe. And you have to say how big the figure is. Sorry, again, I'm getting sassy. It's a fine library and very useful, and I use it all the time. And then you actually have to say that you want to draw the nodes, and you say you want to draw the labels, and you say you want to draw the edges, each of them individually, because that's how NetworkX works. And then removing the ticks, because you don't need those, because space is not important here. Well, no, that's not true. Space is important. Location relative to other points is important. Location relative to the axes is not important. And then a nice little title, and then showing the plot. All right. Oh, it's stinking. Where are we up to now? Okay, so making a list of the whole thing, the big claims, which is good. So we did the little one, and that turned out fine and exactly the same as it did last time. So that's good. Yeah, I think I'm actually going to get rid of those sort of like little examples once we know the big one works. As you can see, we are CPU 407%. We're definitely making use of the compute. It's chugging along. RAM isn't super high though. There's probably something you could do to parallelize on RAM, maybe something in acceleration, maybe. And we could use GPU if we wanted, but I think it'll be fine. Well, actually, I should see. Can you use GPU with NetworkX? Is that a thing? Is there any chance that will happen? Somebody asked in April. That tells me that it didn't exist in April, but it might exist now. As is known to many practitioners, GPU device can accelerate matrix computations, and there's many application of SNA powered by CUDA on GitHub or Project X, blah, blah, blah. NetworkX is implemented in pure Python, so CUDA is not going to work. Numba seems more likely. So GraphTool supports parallel processing. NetworkX does not. Since NetworkX can use anything hashable as nodes, I guess it's hard to increase speed without increasing backwards compatibility. Oh, so your nodes can be any data type that can be hashed, any data structure that can be hashed? I guess that makes sense, because thinking back on it, oh, let me zoom in, it's a little bit hard to read. Thinking back on it, when we first got started, we ended up using nested dictionaries, but I think it said you could also use a matrix or a list of list. Are matrix hashed? Surely matrices in Python aren't hashed. Surely. That would be surprising to me. Hash a NumPy array. Yeah, it's definitely not by default. 2008. Hash to equivalent tuple, but it requires some memory. Anyway, sorry, I'm off on a tangent. Oh, are we done? We are done. Oh no. Look there, we've got some subgraphs that aren't connected to our main graph. Yeah, interesting. Way off track, but something here can help. No, you're not way off track at all. This has been extremely helpful, and also interesting to see. So what we see here is, I want more. I want more of the top co-occurrences. I want the top so we don't need to get rid of that, right? Because the top co-occurrences are all normal words that we might expect. Yes. So let's co-occur edges filtered K for K in, I think I'm just gonna do top co-occur, which is sorted. It is sorted. And let's do the top 50, I think. This might take a second to run. Oop, I made a mistake. Attempting to graph these top 10 co-occurrences. Okay, in top. Co-occur just filtered. Top co-occur 50. Yes, why don't I just change the one thing instead of trying to change multiple things? Oh, sorry, Ryan said some things that I missed. I think that it's the NLP.pipe and large default dict functions slow, not the NetworkX part. Oh, interesting. There is the sparse matrix data type in Python, a possible alternative to default dict. That makes sense. Yeah. Yes. Okay. So as we add more entities, we get fewer subgraphs and more regular graph. So actually, I think one thing that I want to do is this is only looking at things that occur more than 5 times, and I think I'm willing to go down to 3. And I'm actually going to put this into a separate cell so I don't have to run the whole cell every time. Let's run that. All right. Yeah, so we have more things, which is excellent. And let's run that. Awesome. So we can see, oh no. So we can see Washington, D.C. up here. Those tend to co-occur, and we can see down here, I know it's very small, Canadian and Justin Trudeau. So Washington, D.C. is something that tends not to occur with other things. And then we see very tiny over here, the Canada corner off by itself. Awesome. I think it's the spring layout. So let me look at NetworkX layouts. I think I like the one that's more like radial. I think it's called wheel or something. Let's try. Oh, actually, this is where I can use my other notebook. Oh, if I can scroll in it. There we go. Add edges, remove edges, number of edges, degree, edge list, weighted edges, directed graphs, multi-graphs, network models. It might be draw circular. Let's try that instead of this spring layout. Does that work? Oh, that does not work. It kind of works. It doesn't not work. Ryan says you probably need to change the top underscore co-occurs part, which is limiting to the top 20. I think this might actually should be here. Is that my problem? Yeah, that looks good. Okay, let's see. NetworkX spring layout, because I want a slightly different layout. Position nodes using Fruchterman-Reingold force-directed algorithm, which actually I want a different one. The same using a longer function name. Layout. Drawing layout. Circular layout. Shell layout. Spectral layout. And it's just top level. It's right under NetworkX. Let's try GraphViz layout, because I tend to like those graphs. Nope, that didn't work. Module NetworkX has no GraphViz layout. Create node positions for G. And then nx.graphic layout G. Okay. No, it should work. This should be the right. Copy and paste directly from the documentation, and it doesn't work. Module NetworkX has no attribute GraphViz layout. Oh, is it the graph or no? It's at an NX. Well, that's interesting. Let's see what other layouts there are. It's going down here. B, E, F, G. G, R. Graph matrix. No, it sure don't, huh? Well, I guess I can't get that layout. Noted, and it has layout at the end after an underscore, so I can't see all of the layouts in one nice place. So I'll just live with that, I guess. Okay, it's 5:01. I do need to get going. So, yes, but we have, and I'm very excited to announce it. If I actually run the code, we do have, oh, you know what? I bet it's probably figure size. What if I made it 12 by 7? Would that squanch it up? It would. It does make it harder to read, unfortunately. What if I did it 20 by 10? I'm so spoiled coming from R. I don't want to have to do this by hand. I want it to happen magically for us. So we can see that we have, in fact, a graph that talks about what things tend to be mentioned together. So no surprise, Justin Trudeau and Canada tend to be mentioned together, American politics, and also Germany. So it looks like Germany is associated to American politics through Muslim. At least in these fake internet rumors that people have made up. We see some states and different political figures. So, oh, yeah, I do need to go. So thank you very much for joining me. Thank you, Ryan, for doing some really nice work. It was very helpful, and I'm glad to see graphs. And I might, oh, let me commit this so y'all can see it. Let me commit it and also make it public. Whoop. Okay, make public. So it's going to take a minute to commit because it takes a minute to run this code, and again, it's being run in a different environment. But I can click out of this and keep working if I want to. And I will see you guys next week. Hopefully this was enjoyable. I definitely had fun, and I'm excited that I didn't have to futz around with dictionaries anymore. Yeah, sorry, I want to keep playing around, but I do have to go do other things. So I'll see you next week. Thank you for joining me, and yeah, have a great weekend. Bye.